Guided exercise number 5 says indefinite integral of negative 5 e to the x all over square root of 1 minus e to the 2x dx. All right, so if you're looking for an inside function in a composition, it looks like maybe a good choice for an inside function would be 1 minus e to the 2x. Okay, so let's try that and see what happens. If you use u equals 1 minus e to the 2x, your du is negative 2 e to the 2x dx. And there's a big problem. We don't have an e to the 2x floating around in our indefinite integral. Let's go ahead and take that negative 5 and just drag it away. And what we have is 1 over square root of 1 minus e to the 2x times e to the x and then dx. And so the problem here is that we don't have an e to the 2x floating around to be the derivative of u. It's just not there. And so this actually doesn't work. Does not work. And I showed you an idea that doesn't work because it does seem like it's fairly plausible given the makeup of this integral. And sometimes when you're working these problems, you'll have a situation where you think you've got the right u, and you go and look for du, and you just can't find it. And what that tells you is you need to find a different choice of u that will actually work out. Now, in this particular example, it looks like based on the structure of things, at least more or less, this e to the x dx needs to be your du. And so that suggests a different choice of u. What that suggests is that the u that we use should maybe be e to the x. And then the question is, can we find it somewhere in our integral? And we can. I was debating on color choice for a moment there. So let's write this as the indefinite integral of negative 5, 1 over square root of 1 minus, here's the trick, e to the 2x is the same thing as e to the x quantity squared. And then we've got times e to the x dx. So we've already said that it looks like e to the x dx should be our du. And in fact, that's what we would get from the u that I've proposed to you but have not backed up yet. So du should be e to the x dx, we think. And the way that I have just written the integrand, you can see here's your u. So now you've got u as an inside function in a composition, and then you've got times the derivative of u, explicitly written down within your indefinite integral. And so now you're ready to go ahead and do the substitution. So this is the indefinite integral of negative 5 times 1 over square root of 1 minus u squared, and then du. Again, much less complicated indefinite integral. So now we evaluate the indefinite integral, and it's one way to do it is negative 5 arc sine of u plus c. You could also use a multiple of arc cosine instead, but you can use either one and it doesn't matter. I tend to default to using arc sine. And now your very last step is to go back and put the x's back in. So this is the same thing as negative 5 arc sine of e to the x and then plus c. And we might as well go ahead and do a check step. We'll squeeze it in at the bottom. So check, let's take the derivative of negative 5 arc sine e to the x we get negative 5 times 1 over square root of 1 minus e to the x, having trouble squeezing this all in here, e to the x quantity squared, and then times the derivative of the inside function, so times e to the x. So let's check that against the original integrand. And yes, it's the same because e to the x quantity squared is the same thing as e to the 2x, so this checks out.